We've got such a small group. Just, if you've got a question when I go through stuff, just yell it out. The I don't have a lot of code stuff, so it's mostly an overview of Cloudflare. So the Cloudflare ecosystem. So let's see here. Get down to slide number 2. First, the requisite commercial ad from our sponsors, from my sponsor at Cumulex, which is where I work. We are looking for a DevOps person, singular, back end, I think plural, more than one, and a front end person. So I'll tell you quickly the technologies we use on the front end right now. We use Vue, although I just finished up some React that is in some web components that I've done for our product as well. So that could be a future talk, writing web components in React. Anyway, the ins and outs and the pains and tribulations of web components. So we are looking for someone, not entry level, probably some junior, senior front end Vue. If you have React, great, then you probably come and work on that, but work with me too. It's all TypeScript. We are on Vue 2 right now, which really sucks because the code base is so big. We haven't been able to migrate to Vue 3 yet. Our back end is also TypeScript and Node, and a thing called Hasura, which is a GraphQL database that layers on top of Postgres. So if you have any buzzwords of TypeScript, Node, Postgres, Hasura, those are the ones for the back end. And then the DevOps are all Kubernetes, Nginx, all that sort of stuff. So we unfortunately recently lost a couple of guys because we got some people saw their skills on LinkedIn that got developed at our company and plucked them away. So the problem with COVID, it's good because we can now hire from anywhere. That is also our biggest problem because anyone else can hire from Indy. So before we had there's enough jobs around in Indy. Nowadays, it's really good. You can migrate around, but it's not like the Valley where, people headhunters were always hitting you, because up until recently, someone from the Valley could hit you up, but you had to move to the Valley, and most people are in Indiana for some unknown but valid reason. One of our guys actually got plucked by Zoom. So he's one of our guys is working, what we do. So what we do is we're doing cloud-based video and access control. So we do lots of streaming video stuff. So of course, recruiter sees streaming web video, and Zoom calls them and hires them away. And Zoom is able, especially because of their exponential growth right now, they're able to allow for a lot more salary-wise than we as a startup can. So that's a bummer. But if you know anyone in Indy or outside of Indy with any of those skills that would like to work in the area we are, I'm going to put the slides up later. That's a link in the slides, or write down the company name, or just chat me up on Meetup, because we need more people. So, okay, end of commercial break. A little bit about Cloudflare Ecosystem. I'm sure probably everyone has maybe heard of Cloudflare, but they're kind of really picking up and expanding their offerings really quickly. The new offerings I'm going to talk about are a little bit more of a toolbox, because they're a bunch of things that you can kind of build stuff out of versus some of the things like AWS and Google and maybe Microsoft offer that are more batteries included. But one of the big things that, it is basically the reason I'm interested in Cloudflare is it's pay by usage, and it's pretty low rate, and the ease of deployment. So as I mentioned earlier, I've done Kubernetes before, and all it does is grow gray hairs on me. So I am happy not to ever work in DevOps or on DevOps again. We have a couple of really good DevOps guys, but I don't even want the knowledge of Kubernetes sitting in my head anymore. So I really love the concept of serverless and things. as a way to eventually get away from things like Kubernetes. So Cloudflare, if you're most familiar with it, is a service for fast DNS lookup. So I use them as my DNS lookup. They are, I think they're 1.1.1.1 and Google's like 4.4. No, they're 8.8.8. I can't remember. But super fast DNS. Don't use your cable DNS server or your fiber DNS. Use Cloudflare or Google. They're much faster. The biggest thing that Cloudflare was selling for many years is DDoS attack protection, and as a CDN, a content distribution network. Most people or large companies typically use Cloudflare to front end their sites and their systems to do the DDoS, CDN, and also rate limiting. And that's what most people added. And then a couple of years ago, I mean, it's really pretty recently that they added Cloudflare Workers, which was their sort of first foray into serverless. But first I want to talk a little bit about their CDN, which is what they the first thing came out with. They first came out with a generalized CDN. Oh, no, I guess this slide, I haven't gone through these slides yet. I wrote them, I haven't gone through them, so I'm trying to remember what I wrote about. So this is a bunch of the new features that basically I'm going to talk about. Like I said, they have a super fast CDN to serve your web pages. They have these serverless Lambda functions, which they call workers, and we'll explain why. They have a serverless key value store, which you can use kind of as a cloud database. They have a thing called durable objects, which is really weird how it works. It's kind of confusing. Architecting for it's hard, but I'll kind of explain how some of it works. They have extended linked Lambda functions for serverless compute. AWS has some similar things. They have Lambda, and then they have you can run Lambdas longer to do cloud computing. And AWS introduced a new. They have Lambda Edge, and then they also have Cloud something else. They have a few things that are kind of similar to some of this. Cloudflare also recently just opened up GPU access in Workers. There's very little documentation on it, but I'll tell you what at least I know about it. So those are sort of the package features that Cloudflare has come up with, and almost all of that is within like the last 2 years. So they've obviously got some internal plan as to where they're going with all this, and they're executing it pretty well. Like I mentioned, competition, CloudFront functions, that's what they call it. So AWS is Lambda. Does everyone know what AWS Lambda is? Lambda functions, if I talk about that, is everyone pretty good with that? Okay. I'm not going to go through and explain. They're basically singular functions that run in the cloud and do something. Lambda was like the grandfather of all of this. They came out with Lambda Edge, which is pushing the functions out to the edges, to the compute centers for better performance. And then because of Cloudflare and Cloudflare Workers, which are their Lambdas, AWS had to introduce, or they did to compete back, a thing called CloudFront functions, which are extremely fast, extremely low latency Lambdas, but they can do almost nothing. The restrictions are incredibly high. It's mainly built if you've got to echo back some small amount of data or reroute something else. I mean, it's like you're limited to like a page of JavaScript. It's really bad, but there are uses for it. Google has Firebase functions, which are the same thing as Lambda. They have Google Cloud Functions, which is really the same thing as Firebase functions. They just rename them. And then they have Cloud Run, which is also sort of like Lambda, and it's also sort of like AWS has the same thing. It's Docker in the cloud, Docker instances in the cloud, separate from Kubernetes and things. And Microsoft has Azure Functions and a similar suite of things. I just haven't played with them, so couldn't name them off the top of my head. That's the competition, but they're taking a little bit different approach than the rest of the guys. I'll explain what it is. So this is all serverless, which I think is new and improved in the wave of the future, and would love to see Kubernetes just go away, etc., and be replaced by this. Of course, serverless is a little bit of it's say an oxymoron, but that's not actually the right English term for what that I'm looking for, because there are still servers involved, right? So what it really means is reduced effort on the developer's part for doing some kind of server thing. The other thing too is that Google and AWS and everyone says, yes, these cloud functions are stateless, and that's also not true at all. They do persist for some time, and I can talk a little bit more about why that is and why that is actually very important. But I remember years ago when AWS first came out, my first thing was I wrote a little function, put it up there, and then I thought, this is so cool because every time you hit this endpoint, it's going to totally wipe this thing and rerun it. So if you have a memory leak or any kind of bug or something, it gets reset, right? It's the Groundhog's Day of server stuff, right? It just keeps repeating. And that's not really true. They are short-lived things, but they do actually have state, and they can maintain state for their life. And that life could be anywhere from 30 seconds to 30 minutes. So they don't totally reset every time someone hits an endpoint. It's something to keep in mind. Let's see here. So the first thing that Cloudflare has recently pushed is what they're now calling Cloudflare Pages, which is you can host a website up there. It's super fast CDN. I've got a link in here somewhere. You can hit their web page and you can hit refresh, and it's typically any of the stuff that's in there is happening in 12 to 16 milliseconds, which if you build any cloud systems it's remarkably fast, at least in my book. It also, they have a whole bunch of interesting metadata that you can get on the visitors in your pages. Kind of makes you wonder about some privacy stuff, but it tells you where they're coming from, where they're at, different. It's basically like analytics built in that you can get in your pages without putting analytics code in your app. But that's the first thing they started pushing. One of the cool things about it is that basically they give you a GitHub action. So if you put your site that you're building on GitHub, you install this GitHub action, then whenever you push to your site, it will forward your site over to them, and they will do the build there, and then they will actually create a funky named URL. So if it was for Cumulex, it'd be Alpha Barbie wombat-cumulex.cloudflare.com or something. Every single push, they basically build you a whole new website, and you can hit each one of those. And I'm not sure how long they persist, but the whole idea is that they want you to be constantly deploying, they're building it, and to have anyone else basically previewing and constantly working with your site. Like I said, automatically generated links on every commit. Unlimited seats, you can add however many other collaborators you want. In the pricing, I'll show you can have unlimited websites and unlimited, I think it's bandwidth, which is really crazy. They also, because they're constantly pushing up these copies of your site, you can control who can see the previews and which ones you actually want to get deployed over to your official domain. They also have pretty good, I think I've got some in here later, privacy first based analytics. They've got a package, so it's like Google Analytics, but it's totally free. And they give you all the standard stuff like Google Analytics or Firebase Analytics does, which is, how long was your first paint? How many people are coming in on iOS? How many people are coming in Safari? How many people are coming in from France, whatever. And that's all free, which is pretty cool. It's free with your paid Cloudflare Pages account. So it's not totally free. Just pricing is kind of relevant in all of this, so that's why I put pricing all these things up here. So you can sign up right now for free, and it's crazy. You get unlimited sites, unlimited requests for your sites, and unlimited bandwidth. And you get, if you want to use the GitHub action, you can deploy the pages manually to your site. But if you want them to do the build through the GitHub action, then you only get, it's sequential one build at a time, and you only get 500 builds a month. But that's pretty darn nice for free. And then if you want to pay $20 a month, you get 5 concurrent builds. You know, if it's you by yourself, you don't need 5 concurrent builds unless you are really editing really quickly, and you get 5,000 builds per month. But again, it's unlimited sites, unlimited requests, unlimited bandwidth. So if you're doing your own fun project and stuff, sign up for the free one. It's awesome. And if you're a business and you've got a company, and do that thing. But it's pretty generous in my mind. Like I said, analytics are free. This is a little demo of their analytics. I clicked on the wrong thing here. It's just, it's the same kind of stuff that you see on like Google Analytics. And you can set up tags for pages and clicking on things. I mean, it looks at least very similar to the Firebase Analytics that I've used, and then some of the Google Analytics. Some of the Google Analytics gets a fair bit deeper, but that's all free, so you don't have to pay for the analytics. Let's see here. So that's their pages offering. So that's sort of their foundation. So then they added on top of that Cloudflare Workers, which are their Lambdas. But wait, what makes Workers unique? So first let me describe how it works over on AWS and Google and Azure. So Lambda functions over on AWS, and the Google functions, cloud functions, they're actually running effectively internally on a Docker instance. So they're spinning up a small Docker instance, which is basically running your function in Lambda or Google Cloud Functions. And this is why, if you're familiar with AWS, this is the terrible cold start time that people talk about, that they get upset about. There's warm start times and cold start times. So basically, to invoke a function, you hit a cloud endpoint, HTTPS endpoint. The instance there realizes it's yours, and if it hasn't been running for a while, it's basically going to instantiate that Docker runtime with your function. They do some optimization, so it's not quite as terrible as it sounds. But if you've played it all with Docker, in instances, you know it doesn't come up in a millisecond or two. It's an issue that a lot of people have with using cloud functions, that, for instance, if someone's on their website and it's going to hit the cloud function, and it either needs to warm up one because there's none running, or it's warming up one because concurrency, more people are hitting the site. Sometimes you can have latencies, up to in the seconds range, which for some sites, if people are used to just, smacking on buttons and having things happen immediately, can be disconcerting. The beauty of that, because you do that, they can use many node packages. And in fact, when you do a Google Cloud function and some of the others, you actually give a package.json with your packages. Can't use all node functions, but you can use a lot of them. And it also allows Google Cloud Functions, I think right now, can support like Python and a number of other languages, and same with AWS Lambdas, and that's because they're running Docker, so they can just throw in another runtime. Cloudflare Workers are very different. They are using, which I've got, I think on the next slide. Let me see if we've got the next slide here, and I'll go back. Yeah, I'm going to do these slides out of order. So Cloudflare Workers are based on the concept of a thing in your browser called a service worker. So if you're not familiar with it, all the browsers currently running and stuff, basically have conceptually a thing called workers, which are basically ways that you can spawn off more JavaScript code to run on effectively another thread, another CPU. That's built in, and it's actually been in the browsers for quite a while, and the adoption of people using it is incredibly low. But it is a pretty handy thing to allow you to multi-process inside your app. And the issue being, of course, if you've done much web development, if you've got something that's interacting quickly with a web page, it's very possible that you basically hog too much CPU time and you starve the event loop, and then someone goes clicking on their button and nothing highlights and nothing clicks and things like that. So workers, people have used in different websites to spawn, the common example of that, which is no one ever actually uses in a real website, is to go, compute some massive factorial number, and they demo that if you do it in the browser, that buttons and things just suddenly stop working for 5 minutes, and if you put it in a worker, then everything keeps working. So workers are great, and somewhere along the way, when they had those, the Chrome guys came up with this concept of a service worker, which is yet just another worker like the regular ones, except for it has some special properties. And essentially a service worker, you can only have one of them, is effectively like running a little server inside your browser. So you're running a worker, but it is allowed to sit in between your network connection and the outside world. So you can actually put stuff in there and serve things from HTTP endpoints. You can cache things, you can do everything else, because it actually is a little piece of code, like I said, sitting right between your browser app and the outside world. I have actually implemented a GraphQL server inside a service worker, that inside the service worker, it served GraphQL to the application, but the service worker made requests to just a regular database with an API on HTTPS. So, but as far as the application was concerned, it was still talking to GraphQL. The beauty there was if you wanted to move to some other GraphQL thing, you potentially could, and you just take the service worker out of the middle. They work pretty well. They're a pain in the butt to debug. But the Cloudflare guys saw that concept, and then they picked out one other concept that Chrome had. So years ago, if you remember, if you were using Chrome back in the good old days, or Safari, or Firefox for that matter, your tabs were not isolated. So if you bought in 4 or 5 websites and one of them was really evil, it could take down your whole browser. Aside from being an incredible security leak, somewhere along the way, Chrome, I think, was the first one to do it. They came up with this concept of isolates. And basically every tab that you run inside Chrome is its own little mini container, and you can't affect any of the other tabs. So it's a containerized thing, but it's a super lightweight container. So it's not like Docker, which is a very heavyweight container, and or Kubernetes being a heavyweight container manager. These things are very lightweight, and you probably noticed it because, when you open those 300 tabs like I do, the browser still kind of keeps working. You open 300 Docker instances on your Mac, you'll start having some problems. So because they are super lightweight, a single runtime can instantiate and handle thousands of isolates. So the Cloudflare guys said, hey, what if we steal this stuff from V8 and Chrome, and what we will do is we'll make our workers be isolates, and we will make their API be the service worker API. And so that's basically what they did. Let me go back to my previous slide, which the restrictions behind that are AWS Lambda, Google Cloud Functions. You give it a package JSON, you say go, it pulls in, when you deploy it, it runs that thing, starts it up, pulls the packages in, runs the little Docker thing, runs your Cloud Function. It's almost like you were still running Node on your local machine. That's not the case. When you run a Cloudflare worker, you have to use Webpack or something and compile it down to a single JS file. And that JS file is your service worker file. So there are no go fetch packages, pull things in, do all this stuff. If it can't be something that can be webpacked, then you can't stick it in the worker. There are all kinds of polyfills for Webpack for compiling things down to non-node systems. And they just recently updated it now where they claim that you can pretty much handle any node package. But again, you can't handle every node package because there is no file system. I mean, you really can't do this either in AWS Lambda or Google Cloud Functions, but Node is actually there behind you, so you can do some weird node queuing things. You could potentially write to a file system if there were one. None of that exists in a Cloudflare worker. So the best way to think of a Cloudflare worker is truly a service worker running in your browser. That's the restrictions it has are the same restrictions that this Cloudflare worker has. But you can write in TypeScript and JavaScript, and it does have WASM support, just as the browser has WASM support. So Rust and Go and Grain and all these, there's a ton of languages now that can actually be compiled to WASM. So you can actually run those in a service worker. And in fact, they actually have support for JavaScript, TypeScript, and Rust. The other ones you can do as well, but they don't really push them or support them. Let me go over here. So if we crud, hang on a second. I want to go there. Do I have that open there? Examples. Let me see if I put these. So yeah, we're going to switch screens for a minute here. So, see that okay? Yeah, it's kind of blurry on my screen. Sorry that's blurry. I'm not sure why some of these things are a little bit blurry, but they have this page that basically has examples. So I don't know. Let me see if I can zoom this up here, but hang on a second. So let's look at this this one up here, which hopefully you can see. So this is a little web server basically. So what this is doing is it's basically saying this async function. Your main handler for your service worker is also always an async function that handles whatever request is coming in. So you have to implement one of these, and all this does is it says, here's some HTML, handle the request. To handle the request, we create a response similar to how you would in Node. Here's the HTML, and here's the headers. So now you have a really dumb, only one web page server, but you can actually run that and deploy that as a cloud function. They have other examples on this page. I've got the links in the document, but you can go through these, and these are really useful if you're trying to get started with it. Again, just like over here, return some JSON. You can also go, you don't have any ability to read, write files, things like that, but you can do use the web fetch API to go and fetch things outside of Cloudflare that you want to return or access. Redirects, things like that. I won't go all through these, but if you want to play with this stuff, I'd recommend you go through them. These are all pretty short. They give you good examples on the types of things that you might be doing, because a lot of these are meant. One other restriction I didn't put in there is you are limited to 1 megabyte of code. So that can be a thing if you're trying to run like a really big back end. Now that 1 megabyte of code is 1 megabyte gzipped. So it can expand to something bigger than a meg, but when you upload it to the thing, a meg is they basically keep that off when they're going to instantiate it, and you can't have more than a meg. I've actually written them a few times because I was trying to implement a really big GraphQL backend, and I got it under a meg, but it would have been easier if I didn't have to stick in a meg. And they said they're looking at upping that at some point in time. You are also limited to 128 megabytes of memory. So you're not going to do any giant memory things. But again, these are very lightweight, the isolates. So it's not like Docker where you've already got, a Linux kernel and 100 zillion other things loaded. That 128 meg is all totally for your code itself, for your app that's running. No APIs, no runtime stuff. So 128 meg is actually a fair bit of RAM. And that's not your code, that's your RAM that your function is using. Another restriction that's important is it has to return in 50 milliseconds. So you can't go out there and run a 10-minute computation. Now, the cool thing about it is that 50 milliseconds is 50 milliseconds of CPU time clocked inside their cloud function on their system. So if you go out and you do, which you can't do, which I'll explain again in a minute, but you could do 100,000 fetch requests, and that took 3 hours to return all the data. But once the data was there, you didn't consume more than 50 milliseconds. You are still within the 50 milliseconds. It does not count any off-site fetching async stuff into that 50 milliseconds. So initially that 50 milliseconds seems really onerous until you realize, okay, it's really not that bad. They did add an option to fix that, which I'll talk about in a little bit as well. But so there are a few restrictions. And as you notice on here, the things that they tend to show are more small items, that are doing webby housekeeping-ish kind of things. They're not showing you how to do a whole GraphQL TensorFlow-based, backend here or something. And that's not what this is targeted at. So their whole thing is lots of lightweight functions, potentially all interacting with each other. So let me go back to the slides here. And I've written some Rust and put it up there, and it does actually work really well. And it's really, really tiny. So that is the beauty. If you have something that needs to run fast and it needs to run in the 1 meg and you can't fit it there with JavaScript, you can use Rust, compile it to WASM, and typically get more bang for your buck. But Rust is a whole nother thing. Let's see here. This page, I just went to the examples one. I'll show you over here again. Let's see here. They have really good documents. So they have a pretty good getting started. Let me zoom this up again. Looks terrible. Okay, that's still not great. Like I said, they've got 200 data centers around the world. And the beauty is that when you run these Cloudflare workers, they run everywhere. So if you built cloud functions or AWS Lambdas or whatever, you usually go up there and you pick your regions. So you pick US East, US West, whatever. You don't pick regions here. These things propagate across the planet. So the beauty is that the person over in India will get the same response speed as the person in Indianapolis. Which, if you're going to do that with Firebase, AWS, anyone else, you have to run multi-region things, and that gets expensive. So that part is pretty cool. You can sign up for a workers account. There's a free version. I'll show you the price in a bit. You want to play with it, it's really great. They have a CLI app. It's called Wrangler, and you basically use it. And it has kind of built into it some Webpack building stuff, commands to deploy, and all of that. You can do those independently other ways, but it's just far easier to install Wrangler. They just came out with, if you're like me, who likes to live on the bleeding edge and has a Mac M1, they did not have Wrangler working when the M1s came out, so I had to run it in Rosetta, and that caused a whole bunch of grief. They just recently released M1 version of Wrangler, so it's all cool now. But it allows you to create new projects. They've got templated projects. It allows you to run local. It allows you to push. It allows you to run in kind of a mixed mode. But the documents are pretty good there, and they've got some quick starts, which are the easiest way to go. I started with like their TypeScript starter, but they've got a few different things. They've got this Apollo GraphQL server, which is super old right now, so it probably wouldn't even work if you updated the packages. But that's what I looked at when I was first trying to do my GraphQL backend in Cloudflare. They have this really cool new thing called Flare React, which is basically if you're a React person, you're familiar with Next.js, things like that. It's basically for doing dynamic server rendering, routing, blah, 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 all the same kind of stuff, but it's a package they built specifically for Cloudflare workers and pages. So it's really fast. I don't know how well it'll be adopted, but it's pretty cool. So check it out. What else they have on here? They have, which is really handy, which I used, Sentry.io, which is a JavaScript bug reporting, issue reporting thing. We use it at Cumulix in our browser app, but the Sentry also updated it, and you can use it in the Cloudflare workers, because they can sometimes be just a little bit, well, they can be pretty much near impossible to debug once they're deployed. They have a way where you can tunnel logs from them back. It's a pain in the butt. So I use Sentry when I'm trying to debug the Cloudflare workers. Sentry, again, has a huge free tier, and you can catch things there. But they've got a lot. They've got boatloads of examples, which is really nice. I think they can run Python now, I guess. I can't remember. They're doing some new stuff all the time. Most of these things compile to JavaScript or WASM. That one of their big things is that through a whole bunch of WASM stuff and everything else they can run COBOL as cloud functions. So I think they're targeting all these legacy system people that need to move things off their AS, not 400, I don't know, 23, whatever the hell the ancient IBM thing is, and they want to put it somewhere else. And so they've got they've got this accounting system for the state or something. They want to put it up there. They pushed a lot of COBOL stuff, which is, it's just hilarious to see. But these are really great. So you can go up and documentation, is king a lot of times when you're trying to learn something new, and they have got so much of it. So that part is super great. Let's see here. Next. So this is just what I was showing earlier. This again is a service worker. If you build one in the browser, you basically do that exact same thing. Add event listener. So when I did my GraphQL in the service worker in the browser, you deploy your service worker. Your service worker is its own bundle of JavaScript that runs in your browser separate from your regular one, and it creates an event listener for fetch. And that, again, is exactly like the browser, which basically intercepts the network requests that you send out in your browser. And then you can respond with whatever you want, or you can forward it back on to fetch. There's actually a way where you can just bypass it and tell it to continue on. So it allows you to do really weird intercepting things in the browser as well. You can actually track and log all the endpoints you're hitting, and who knows what. It's a lot of weird things. But then they handle requests. So it was pretty slick. I don't know. I've never seen who got the credit at Cloudflare, but it's pretty slick whoever came up with this thing and said, hey, we'll just rip this off from Chrome. Believe it or not, we had some issues at Cumulix. We do all our video through a thing called WebRTC, which is peer-to-peer video serving. And that works great in Chrome, but the WebRTC libraries that are available for Node are pretty sucky and don't work well. And at one point in time, I looked at whether I could just deploy bunches of instances of Chrome, of Puppeteer on our server, and then feed the stuff into Puppeteer and then have it connect through WebRTC to the clients. Because it can handle thousands of isolates, but it was too risky, so I didn't get to try that. So anyway, different solution. But again, they had some pretty cool stuff they got there. They give you, along with this, and this is free, they give you a cron triggers. So this is a little animated GIF showing you can set up cron jobs, and then you can set up the endpoint on your cloud function that you want to hit. So basically, it's every X minutes, whatever, it's going to hit your worker, your Cloudflare worker with whatever the JSON that you put in this thing, and that's free. So that's really handy. That was something that was missing for a long time on Firebase, and they finally added it. I think it was just about a year ago. It was a pain to do. You had to create your own node server just to run cron, which is ridiculous. So they have that. That's free. That's pretty cool. So how much does this stuff cost? This is sort of the a la carte, what they show. Free, you get 100,000 requests per day. And again, they don't, Lambda and Google and everyone talk about CPU time and memory and all that. That's all fixed on this. You can't go over 50 milliseconds. You can't have more than 128 mega memory. So you won't see that in the equation here. But like I said, your workers run across all 200 data centers across the planet. Your worker has its own subdomain off worker.dev. Oh, I said 50. Sorry, I'm wrong. 10 milliseconds of CPU time. It actually seems like that's like super tiny, but the GraphQL server that I ran worked really well. Didn't have a lot of problems. And again, it's the lowest latency after your first request. It does have a warm start, just like AWS and Google, but the warm starts are in tens of milliseconds instead of in seconds. And then you also get some limited workers KV, which I'm going to talk about in a minute, edge storage. Once you go over those requests, then basically you go into the paid part. If you put your account in and you turn it on so that you go to the paid part because you think you're going to exceed these other parameters. So the paid, you get 50 milliseconds. I knew there's somewhere in there. The problem is they will minimally charge you $5 a month. So don't turn that on until you're sure that you've exceeded the free stuff, because if you're using the free version plus one request, you'll automatically get paid for another, 50 cents? So another 10 million requests, even though you didn't use them. So 50 cents per million requests, pretty good deal. All things else, like I said, same, except for you go to 50 milliseconds of CPU time. I'm on this paid one. They charge me $5 a month, so it's not, for playing around, $60 a year isn't that much money. So, in my humble opinion. So, let's see here. But they also do. This is a little bit more detailed on things, and here they call it the bundled, but basically it's $5 a month is the same thing. So, if you look at this, a couple of more interesting things are the key value storage stuff, which I'll talk about in a minute. You can see the limits on those. It's fairly limited on the free tier, but it's pretty big. 10 million read operations per month, 1 million writes, and then all of those are pay as you go above that. The 30-second duration per request we'll talk about in a minute. That's a new thing that they have. You pay for that, though. Your basics, you get 30 workers, up to 100 namespaces. So when you create these KV databases, which we'll talk about in a minute, you can create a namespace per KV store. So you can think of namespaces as databases in the KV parlance. So you can have 100 of those. You get a gigabyte of storage in this KV database. And again, everything is deployed everywhere. They say high runtime performance with no cold starts. It's near no cold starts. Two things that they do. If you have not hit the function in a long time, no one has. It has to instantiate it. They will overlap the instantiation with any like CORS request or anything else. So the first time you hit other requests, you're like doing a cross-origin thing, it will overlap and start that thing up before you actually get the real request. And that hides the cold startup. But I have seen, even with that, on the GraphQL stuff, I've seen 10 to 50 millisecond cold starts. If I don't, since it's my own account, no one's hitting the back end. And if I let it sit for 5 hours and then hit it, that first call is 50, could be even up to 100 milliseconds long, which again is still astounding and fantastic compared to Firebase Cloud Functions. I could see sometimes 4 to 8 seconds for a cold function to start up. And that, at that point in time, your user thinks that your website's frozen. So then they leave, which is not good. So again, pretty cheap. Pretty cheap, I think. So the problem was there were some people that wanted to do. They really love Cloudflare. They thought, well, this is awesome. 50 milliseconds isn't long enough. So they came up with a new thing called Cloudflare Workers Unbound. And it's used for long compute. There's a guy that's doing bioinformatics genomics, and he spawns off hundreds of thousands of workers because this stuff scales. So the fact that you can only do so much time on one worker doesn't mean that you can't run, 100,000 workers in parallel. But the problem is, still even at 50 milliseconds is a little bit too low. And as they show you on here, this new version, Unbound, is limited to 30 seconds, which is relative to 50 seconds is a big increase. It still may not seem like a long time, but it does allow you to do things. And once you get to the 30-second point, you can start doing like pipelined functions. So one function does something, it hands it off to the next one, which hands it off to the next one. You break your compute up. So, and again, as they said in here, no external async requests are ever counted into your time. So, it's pretty cool. There's a blog article I think I put in here, and it's on their website, where the guy talks about doing this massively parallel genomics research in the cloud for an incredibly small amount of money. So, if you were trying to buy raw compute time on like an instance on Amazon or something. So this is the when you're on your workers, it'll pop up this little thing that says, do you want to enable workers unbound? Basically means that they can bill you for it. Once you turn it on and at this point, you're already on the $5 a month thing. So included in that, you get your first million unbound requests, which is 400,000 gigabyte seconds of duration. So that's a fair amount of compute time, at least in my book. I don't know. 400,000 seconds is a long time. And you get 5 gigabytes of egress. And then below, you can see basically the pay as you go, the rest of it. And then you get an automatic, after your first month, you get automatically 10 million bundled requests per month. Things change a little bit, but yeah, it was basically when they first came out with workers, people complained about two things. I want them to run longer. That was the biggest complaint. Number two, like me, I want to be able to put bigger programs on there. So they also announced this thing like 2 weeks ago. So it's brand new and there's not a lot of info on it, but it's called Cloudflare Workers GPU. They've done it in conjunction with NVIDIA, and basically in their data centers now they have NVIDIA. I can't keep track of NVIDIA's numbers. It's like their hottest, newest server-based GPU. It's like an A1000 or something. And what they do is in the workers, they allow you to access the GPUs. So I'm pretty sure this genomics guy is going to be like super duper happy. They have one example, but they don't even really show how to deploy it. And it's basically the hot dog, not hot dog from Silicon Valley. So, and they do it in the cloud, except for you can upload whatever image you want, and you can say this image or not this image. So what they give you is a Jupyter notebook with Python in it, but they don't talk anything. I know. I think what you can do is they've got a thing and you can deploy the notebook to the GPU worker, but it seems hugely inefficient. And there's no info on pricing yet, so it's mostly they're just in blog articles. I think it's in like alpha, but I'm pretty pumped about this because this is pretty slick too. I was just starting at Cumulex. I was just starting to work on video analytics. So for security, of course, you want to be able to, say, show me the bank robbers in the red cars as they were taking off, kind of thing. So you need to go through video and you need to process it. And that's an incredibly CPU intensive thing. So having something like this would be really slick. And just for my own personal projects playing around. They do say they support TensorFlow models. Any of the TensorFlow pre-trained models you can deploy somehow. Again, I don't know how. Pricing, who knows. The NVIDIA cards that they have in there are, I think they're $10,000 or $20,000 cards. So I'm sure you're going to pay something for it. So I keep you posted on that one. But it's good to know that that's coming down the pike. But more real right now, it was in beta for a while, but it's also released now, is Cloudflare Workers KV. So this makes Cloudflare Workers a heck of a lot more interesting. The problem with Lambdas is if you want to have state, because these things don't have any permanent state, what do? Well, you might set up a Redis instance, you might use something or another. Google says, oh, you want state? Go use Firebase and Firestore. Makes sense. Okay, I got you. So what these guys did was they came up with KV, key value, and effectively any database that has ever existed is fundamentally at its bottommost structure, a key value store. But they don't give you a database here, they give you a key value database. So the easiest thing is, if you're familiar with Redis at all, is to think of this as basically Redis in the cloud. It's actually a lot cheaper than any Redis SaaS that I've seen as well, and it's pretty darn fast. The way it works is that it's a distributed key value store, and it's distributed across all 200 data centers. So if you're, let's say, again, in India, and you're hitting the key value store, the reads and the writes are very fast for where you're at, and the reads or writes are really fast in Indianapolis, but the propagation of data can be up to 60 seconds. So you do have to do some interesting things. Also, since it's a key value store and since there's no transactions, it's last one wins. So, if I go and, write my thing, and then, it's typical database stuff. How do you handle concurrency? But the issue being that if there's people on opposite sides of the planet, it could be 60-second different, which could do a lag. There's lots of ways around this. You can put in timestamps and log things and do various things. I actually use it. Actually, here's a little bit better write-up of it. So it's an eventually consistent model since it's distributed across the planet. So, like I said, writes are immediately visible to other requests in the same edge location, but can take 60 seconds to be visible in the rest of the world. So you do have to do a little concurrency thinking. However, it works really well for things. So in this GraphQL server that I deployed to the Cloudflare function, the server takes a JOT token for authentication. Not the server, the Cloudflare worker takes a JOT for authentication. Well, decoding a JOT takes some CPU time. So, but once I've G-coded a JOT and I've verified it's okay, JWT, JSON Web Token, if anyone had questions, just ask me. I've decoded that, it takes some time, but once I've got it decoded, I have the information in it, and I also have its expiration date. So what I do is I stuff it in the key value store, and the next time someone logs in with that JWT, I just look it up in the key value store, which is like instant. And so I don't have to decode the thing. Now what I do is I know the current time, so I always look and see what the current time is versus their expiration time. And then if it's expired, if you have very short-lived tokens, let's say, then I'll go through the whole JSON, the decode again. But I'll stuff it back in the key value store. So the key value store is really great for that. I'll give you another instance. And this may not make a lot of sense if you aren't familiar with GraphQL or GraphQL servers. When I send a GraphQL request, it's sending basically this blob of GraphQL. So it's like a little DSL and some JSON variables. Now, when I send that GraphQL request, it's a string. That string has to be parsed, has to be tokenized, has to be decoded, turned into a GraphQL abstract syntax tree, and then it has to go through and execute that tree. Well, that parsing, decoding, blah, blah, blah on the GraphQL takes time. And again, we only got 50 milliseconds, right? So what you do, and you want to keep these things as responsive as quick as possible, you use the key value store as a big hash for your GraphQL query strings. So I've got my JSON variables, and actually I don't even need that part. Basically what I do is I take the GraphQL string that comes in, I decode it into the AST, and I put the AST into the key value store. So the key is the GraphQL query string, and the value is the decoded abstract syntax tree for the GraphQL engine to execute. So that makes, anytime you hit the next time, it makes it super fast. So there are ways that you can use the key value that are not the traditional database, I'm putting money in my account and taking money out of my account and that kind of thing, which you would not want to do in this because of lots of reasons. But it's very handy for basically state storage. And as long as you're not trying to depend on super propagated state or anything. You wouldn't want to try to do a worldwide game based on this, because the person at the other end might have to wait 60 seconds for your gnome to move or something. So it is a really cool feature, but you think of it a little bit differently. You think of it more like a cache. Service workers in the browser have a local cache that they can cache requests just like the browser caches requests. The service workers that are these Cloudflare workers also have a local cache as well. So they do have a limited form of caching that happens as long as that Cloudflare worker is alive. So not that you would do this, but inside, if you made an external fetch request to an endpoint, and while your function was running, you made the same request to that endpoint again, then it would be resolved from the service worker cache inside your worker instance there. So there's some local caching, but that caching only persists as long as that worker is alive. KV is for long-term persistence. And they give you a gigabyte, basically for free almost. So it's pretty, and the storage is pretty cheap. So it's pretty impressive. Again, this shows you what you get for free. You get a gigabyte, 100,000 reads a day, 1,000 writes. Because of the way their thing is distributed across the planet and everything, it really is, they really want it to be a read mostly, database. So you would not necessarily want to use this for like rapid fire eventing from an IoT device that you're just hitting because you're going to kill it. It's really, I wrote something and I read it. You can see right here, they want this ratio of 100,000 to 1,000. So preferably 100 to 1 reads to writes. But when you go to the paid version, you can see the values there. And then the rest of it beyond that is a la carte, pay as you go. It's pretty reasonable. It's a lot cheaper. Some people have done things depending on what you're doing. It's a fair bit cheaper than, say, DynamoDB, if you are using DynamoDB for the same thing that you could do with KV. So let's see here. So then everyone was going with this database is great, but it's not very real time. So they came up with this new thing, and it is in beta now. It was in alpha. It's in beta now, and it's changing still a little bit, but they're called Cloudflare Durable Objects. And their examples are kind of confusing. But the example that they posted on GitHub, which is pretty cute, is a chat application. So what they do is it's a chat server. So what a Cloudflare Durable Object is that you can create, you can basically create a, it looks like a JavaScript object, a class, in the cloud, and that object can persist. And that object can then actually, through eventing and then WebSockets, talk in real time to different clients. So basically what they show is they show, like I said, a chat server, and it's in terrible raw JavaScript with no React and pure Java. I don't know why they posted it. It's really hard to understand. But essentially what they do is they create this class object, and it's got rooms, and it's got users, and it's got recent conversations and things like this. And then what you can do, like I said, is people can hook to these through WebSockets. You can detect events that basically these work in conjunction with the workers. So I'm going to send a message to my endpoint. The worker intercepts that, and then it sends the event to this object, which then can send some data out over the WebSocket. So I type in, hello Rick, that hits the API on the worker says, send it over to the durable object. Durable object says, oh, Brad and Rick are in this room here, update the text table and stuff, and then send the message, distribute it to everyone else. And the cool thing is it's real time, and it's really, really, really real time. I mean, it's Firebase. Sometimes I can see a few little bit of delays. This is like when you go and run their example, and you go after this, you'll end up chatting with a lot of random people. It's like chat roulette, I guess. But it's really fast. It's amazingly fast. It uses WebSockets, so that's a standard thing. And so their whole idea is that you use this for any of the real-timey things that have immediate persistent data that's maybe not necessarily super long-term persistent. So what they're doing with all this stuff is they're building up a really cool toolbox that you can build something really complex out of. But out of the box, it's just a thing that can do certain specific things. So, if you wanted to build a full chat server, a chat application, let's say, you're going to build your WhatsApp, right? Then you'd have the worker endpoints. You would keep the long-term messages and things persistent in the key value store, because those don't have to be updated immediately. And then you'd use the durable objects for the real-time communication between different parties. And a single durable object can handle, I think they said up to like 1,000 channels and sockets and things. So again, it would not necessarily compete against, like, I think Firebase claims that on a single instance they can have 100,000 people connected. I've never seen that, but there are some limitations here. And let me see what my next slide is. This gives you an idea. So, like I said, it's beta right now. It's not intended for production. It seems fast, but storage size limitations. So your storage, your object this durable, and that's like a durable. It's like a persistent object, durable object. This class instance that you put up there cannot grow beyond 10 gigabytes, which I have no idea exactly why that's a restriction myself. But and there's also no charge right now. So if you want to play with, that's the good thing. You can get on the free tier of the KV and the workers, and you can play with this for free too. And I think it's open beta. I got it on the alpha. If it's not open beta, you have to send them a request and tell them why it is you want it. You can only use it if you are on that $5 a month workers plan. So ignore the previous paragraph where I said you can use it for free. You can use it for free on the $5 per month plan. So it's kind of fun to play with. It's still a little new on the documentation. There's only like 2 examples on GitHub, and it's just a little confusing. The most confusing part, and I don't know if I have this, let me see the next slide. Yep, the most confusing part is WebSockets mean you have a persistent connection open to a client. And how someone does that usually means, how the server does that usually means that there's something live during that whole connection time also on the server side. And of course, workers and things are all about things not being lived long-lived. So they've had some blog posts and things where they talk about it. And the problem is that some places charge by the duration of your persistence. And those get a lot more complicated, because then you have to say, well, how long is the person going to be on chat? And do I take down the socket and reestablish it? And, if not, then if their app is open on their phone all day long and they're connected for 24 hours, yikes, what's my billing on that? So they haven't really come out with the details on this yet. It is super fast. It's really cool. And like I said, in conjunction with everything else, you could build some amazing stuff that has a pretty low overall cost, but that's a caveat right now that is still a little bit unknown. So after they came up with these durable objects, and they're beginning to put this stuff in their KV stuff and everything too, is that they now have the ability to impose what they call jurisdictional restrictions. And what those are is basically restrictions on how long and where your data lives. And this is all for GDPR. France only wants your data to live for, 30 days, and it needs to be deleted, and da-da-da-da-da-da. So this is a new feature on most of their stuff, and you can establish that data from this person has these jurisdictional restrictions, so on and so forth. I need more water. Hang on just a sec. If you only have a US product, then you don't need to worry about this stuff. Sort of. But like at Cumulex and most companies, eventually, if they get very big, start selling things overseas. And then you have to have a data compliance officer and all these other bizarre things. So it's kind of a cool feature that they have. Again, you don't see that in too many other things. So I had my GraphQL server. I haven't touched it in 6 months. I tried to get it building again today. It didn't get built. So I was going to try to demo that, but I might eventually post it somewhere. But like I said, it has some cool things because I use the KV for token decode caching, the GraphQL parsed request caching. The thing does JWT based auth in the cloud. It uses the Google Firebase, some of the Google Firebase tokens and things. So that causes a fetch to go out to Google to get their current public keys to be used for the token decode, which is the other reason that you want to cache the JWT decodes, because if you have to go out to Google to get their rotating public keys, That's another fetch that takes time. Everything takes time. So you want to cache everything, right? So there is, and I thought I put the link in here. It might be on another slide, but there's a cool guy, and it's up on GitHub. I think it's on my next slide, maybe. Let me see here. And he has written a graph database using workers and KV. So I even looked at trying to implement at one point. I don't know if anyone's familiar with a database. It's called PouchDB. It's actually a browser version or a node version of a thing called CouchDB. Stephen and I were talking about earlier. It's pretty cool because it's a logging DB. You aren't actually writing things in place. You're changing data and then writing how it's changed. And so it works really well for something like KV. And I started to look at implementing that on there. A couple other people looked at it too. But you could potentially layer some databases on top of it. But one of the things that PouchDB does is that most databases, and same thing with KV, is that you basically are looking things up by index, or you have indexed things. So when you're looking for greater than something, you've created an index on that something, and that's how you look for ranges and things like that. The problem is a lot of data you can't index, and so CouchDB does this old classic algorithm that Google search uses, which is called MapReduce. And so the idea there is that you basically spawn off a bunch of workers hitting the KV store, and you break. This is in Postgres, everything else is called a table scan. So when you can't index, you got to look through all your data, right? It's the only way. But you can do that in parallel by doing a MapReduce, where you spawn off a whole ton of workers, and they each look through part of the table, and then they reduce down and figure out the results. So you can potentially do very quick table scans. But anyway, a guy has done an entire graph database on KV using all those techniques, and it uses Tinker, I think is what it is, which is a graph database query language. It's an Apache thing. You can look it up. It's not GraphQL, but it's graph query-ish. It's pretty cool. I didn't try to run it, but it was one of the most sophisticated worker KV things I found on GitHub. So they have another thing, which is Cloudflare Images, which they added recently again, and it allows you to poke their thing in front of your buckets. So if you're using, and it could be the KV stuff as well, but they talk about buckets like you'd have on S3 or Google Cloud Storage, and basically it sits in front of it, and it auto optimizes and auto resizes image requests. So if you got your website, you've got a bucket, and it's got your images at 1K by 1K, then requests will automatically, when it hits that, going through this will automatically resize, optimize, and cache all the intermediate size images in between to make things more efficient. So I didn't find pricing on it. It's in there somewhere. So I've got links. These are links to all of the different things on their website. This is a guy at the bottom on YouTube who did a video comparing latency and stuff on Workers KV. That's the one I was talking about. Thunderclap GraphDB on top of KV. Thunderclasp. Okay, I got a typo. But anyway, that's the one. It's on GitHub. It's pretty slick what the guy did. But so, and in fact, what they've done is about a month ago, one of the other, what's the name of it? It's another function as a service SaaS place. I can't remember the name. It's not one of the big guys. It's one of the little guys. They got a version of Doom running in WASM for the browser and deployed off to their, it's Fastly? I can't remember. Something like that. I've never used them. So what Cloudflare did was they took that version, put it on all their stuff, and they added in durable objects So there is a massively multiplayer Doom that you can play real time in your browser against other people. And the source code is all up on GitHub. So it's a good example of a whole ton of their stuff all in one thing, doing something incredibly trivial. Not trivial, I guess. Depends how you want to view it. That's it. They got it. So hopefully by now you have a concept of what's available up on Cloudflare. It's incredibly impressive stuff. Now,